All right.
Let me
Okay.
okay.
Yeah.
I'm taking it off my phone.
Okay. No problem.
Okay.
Okay. So I sent you a document, I believe about an hour ago in your email.
Yeah, the Comptiva chapter 1.
Yeah. And
Yes.
that's where we're gonna get started from. But I need to introduce you to some very basic stuff so that I know you've used the computer before, but this is gonna be different.
Okay.
So if some of them might be repetition to you, but I don't look at it like I'm looking down on you, but we have to
No,
get
no,
the
it's
best.
fine.
Okay.
Actually, I can hear you, but I can't see you. Where's
Okay. I'm on here. I see you and I'm on video too.
okay? You can see me. Hold on a second.
Yeah.
Okay. I don't know where to go to find you. Where to Zoom? Okay.
You see me now?
Nope. Why
I
can't I
see
see
you.
you? Why can't I see you? Huh. Let me oh, okay.
You see
There
me
you go.
now?
Yeah, there you go. There you go.
All right.
Yeah, I had pulled up the other screen and
Okay.
I forgot to I should have minimized it, but okay. I'm sorry.
That's okay. No problem. So
Man,
that's me right there.
make it as simple as possible, man. Because I'm trying to learn something new. I've
Okay.
been out of, I worked at the post office for 30 years,
Yeah.
and I was going to take it easy, but then my wife decided she wanted to move to Atlanta, so I was like, okay, I still got to work then.
Oh yeah. Yeah. That's good, man. So computers, this particular course, like I told you, 3 months will be good enough.
Okay.
But it's going to be involving a lot of your input. Like, you should not be afraid to just open the computer. And I would recommend, if you can get an old one, you can buy online, just an old cheap one. Some of them might be nothing more than $30.
Yeah.
So it
I
become
plan
very,
on
yeah.
looking try to find something tomorrow.
Yeah.
Okay.
Okay. So you can go online, like on eBay. Some of them might just be like not working, but they are willing to sell it. Get a desktop, which
Okay.
you can open, and you'll be able to get familiar with the stuff like what we call the memory chip, the motherboard, the processor, the hard drive. You're gonna be able to see the fans, how the connection are, like from the power supply to the motherboard.
Okay.
So let me go ahead and just share my screen so you can be able to see. I'm gonna bring it up here 1 second. All right, so let me go here. So when we talk of a computer motherboard, this is what actually will sit in that box. When you open the box, you'll be able to see something like this.
Right.
And it's a whole circuit board of different components. So when you look at an example of, let's say, this will be things you see at the back. So we connect the screen to this particular port here. And these two will be the USB ports. And maybe this one could probably be the HDMI. And those are the components we learn as we go. And now the computer itself, the motherboard, will have what we call a battery. Now this is the battery. It's like the size of a 5-inch, like a quarter 25 cents quarter.
Yeah. Okay.
Yeah. So the reason why we have to have it here, because when the computer is working or when it's turned off, there's a clock inside the computer which has to keep up the timing of the components of that computer. So this battery will always be functioning to drive that clock. And then we have the slots. Now at the back, you might decide to extend your computer functionality. For example, if you need additional motherboard, additional, let's say, hard drive. Sometimes the motherboard might not be able to support it, but if you put another card here, you might be able to support additional, let's say, hard disk or floppy disk, or let's say a video card. Now, when you say a video card, we mean that component which this one will connect for the video to be able to see the screen.
Right.
Now, these are the slots. And then this one here, these four, these are for the memory slots, the computer memory. And then this will be a heat sink. It's just a component which actually help dissipate the extra heat the computer is getting. So on this one, this is a processor. Now the processor will generate a lot of heat. On top of that processor, there'll be another fan which help cool down the system. So this is just an overview of what the motherboard is. Now I'm going to go ahead and show you the structure of the computer. So when we say the structure of the computer, okay, there's a drawing like this one right here. Okay, let's see here. So you see here, we have the input. The input will be something like your mouse or your keyboard.
Okay.
And then we have this one here. The whole of this one will actually be sitting on the motherboard. And on that, we'll have its name as the CPU, which stands for Central Processing Unit. And then we have what we call the output. Now the output can be your output screen, where you can see the display, where you have the printer, where you can print your stuff. That's the output. And also it could be, let's say, you can be having, let's say you are dealing a lot with drafting. So we have, instead of a printer, we have like some stuff which could just be drafted out there. So we have like very large printers. So the output here means a lot more than the printer and the monitor.
Okay.
Now the CPU here, we talk of the logic unit, which is the arithmetic logic unit. It's part of the processor. And in here, you see all this. Let me go back here and show you. That will be sitting inside here.
Okay.
That's the processor, the central processing unit. In that processor, we have the component which will be dealing with a lot of arithmetic and a lot of logic. Logic in the sense that it will have to decide and make a decision and give you the results. The arithmetic is the calculation part of it, which will be like the calculator, adding the numbers and giving you the results. Okay. Now, inside the central processing unit, we have also the control unit. This one is controlling everything, including the arithmetic logic unit. So the control unit will be the controller. And then we have the memory unit. Now the memory unit will be sitting here on this. These are the memory. Now we have two types of memory in computers. We have the RAM, which is standing for random access memory. And we also have the ROM, which stands for read-only memory. Now, you might be asking, what's the difference? The RAM will be the one which capture and store the stuff while you work on your computer. But immediately you lose power to that computer for any reason, or you turn it off, the stuff which was in the RAM will be lost. But the ROM is the read-only memory, which will always be there. Anytime you boot up your system, it reads from the ROM. So that's what you see on the display, the black and white stuff which come up. That's coming from the ROM. So the memory unit here has two. We have RAM and ROM. The control unit controls everything. And this is actually the CPU, the control processor. And the arithmetic logic unit is the one which does the arithmetic and also process the logic. The input is the keyboard, the mouse, and anything which we use, including if, say, you go to the post office, what we use for signing, that's going to be the input unit. See, like, hey, that's your credit card. Yes. Go ahead and enter the number here. That's going to be your input. Oh, go ahead and put a signature. That's also the input unit. And then when you see it on the screen or you print it on the printer, then that's going to be the printer, and the screen will be the output unit. Okay. So I'm going to go ahead and send you this one. Normally, I would like to send it to you in your WhatsApp. So you just click it and then you can read it at your own time.
Okay. Now you say you're recording, so is there any way I can go back and watch this again?
I'll send you the recording too. Yes, sir.
Okay. All right. Good.
So that way you get the recording. You also can read this. And if you have any question, feel free to get hold of me, and then I can. Let's say we had another class and you did not understand the part. Just let me know so I can bring it back. Then we can listen in again. Okay. But all this will be available for you.
Okay.
Okay. So this is a basic structure of a computer. Now, they say it has the CPU, it has the CU, which is a control unit. Now, the CPU contains three components: the arithmetic and logic unit, we call it the ALU. The control unit, we call it the CU. And the memory unit, we call it the MU. Remember, in the memory, we have two types: the read only and the random only. So the random will lose all the information in case you lose power. The read only memory, that's where the computer gets instruction to read when you boot it up, when you start the system. And then we have the printer and also the monitor, which displays and also prints out stuff. And then we have the input unit, which is the mouse, the joystick, the keyboard. All these are falling under the input unit. And now, this will be able to help you. I've already sent you the link, but this will be able to help you understand the basics of that computer stuff. So when somebody talks to you about, like, a lot of acronyms will be floating. For example, ALU, CPU, somebody talk of, let's say, the MU and all that. So this is all here. Now, after we cover that, now let me go back and look at the the stuff I sent you. So we can go through that here. Did you get time to read the one I sent you before?
Which one?
The one I sent you in the email, those were
Today?
just, yeah, something with A plus and what is needed and all that.
If you sent me anything today, I didn't, but if you,
Not today. Remember the
yeah,
day, yeah.
yeah, hold on a second. Let me
Yeah.
let me grab that real quick. Hold on.
Okay, cool. So since this class is geared towards A plus,
I
I would
read
like
that
to
one.
just, huh?
I read
Yeah.
that one.
Oh, you did? Okay,
And
that's cool.
and I started reading that, but it's kind of long.
Yeah, it's long. So you really don't have to read everything, but just the basic stuff. So you know, A plus is divided into some sections. There's hardware and there's also the software part. So in this particular option, since you basically want to be able to do and then do the class and then you go sit for the exam, I need to be able to walk you through some of the processes. Of course, we follow the book, and that's a big book. So the book is about 900 pages, but we don't have to read everything in the book. Let me go back here and then I grab the book for you. Okay.
Yeah, I seen where you sent me chapter 1.
Yes.
And I looked at it and it's like, I was gonna print it, then I looked at it, it's like 90 something pages. So I'm like, oh
Yeah,
yeah.
yeah. It might be too expensive by the time you complete printing them. So normally what I like is if you have a bigger screen, you can project on that screen and then you read it.
Yeah.
Then you can make notes out of it. It's probably gonna be easier that way. That we don't take a lot of money just to print it out. Okay. So let's go back here. Now the flow of the controls. Now, if you look at this one, if you look, you see this one right here.
Right.
Now, this is telling you that the keyboard is going to be, when we enter, it's going to be in the input. Now, the CRT, that's going to be the display. Like they call it the cathode ray tube, CRT. And then the disk, that's going to be for the output. When we send, if you're working on a Word document, you try to save it, it's going to go to the hard drive. Before you save it, if you lose the power, that stuff is gone because it's only in the random access memory.
Okay.
And if you're connecting your computer to the outside world or to other computers, you use it in the network. So that's going to fall under the output too. Now remember, anything you do in the output or input, it has to go and be in the memory. So the memory will have to communicate back and forth with the input and the output devices. And in whatever that thing which is in the memory, it's just memory in this case it's an intermediate part of what we try to work with. It helps us save it, but save it temporarily while we work on it.
Okay.
And until you decide to save it, it will be temporary. So for us to be able to save it, there'll be a logic which has to be in that program. And therefore it will send it to arithmetic logic unit. And then the controller will take control so that the memory can save it. And then we send it back, it goes to the output, and then the output will send it to the disk. Or we can send it to the output, and then the output can send it to the network. Let's say it's an email. Or it can be displayed on the screen. So the connection channel between the input and output, and also between the arithmetic logic unit and the control unit is known as the bus. This is the bus. So when you open the computer, you'll get some very flat cables, like between your network, for example, between your hard drive and your motherboard. Those cables, we call them bus. It's a bus cable. They are very flat and thin.
Right.
So they'll be helping you to save the work and also to be able to send the stuff between the computer, input and output, and the processor, and also the control unit. Now, as you can tell here, it's telling you that the CPU, which is a central processing unit, this will be the computational unit of the computer. So without this one, the computer is useless.
Right.
This helps control the operations of the computer and perform its data processing functions. Now, it's usually referred to as the processor. All the actions of all components are controlled by the control unit, which is the CPU. The memory is used to store the instructions, the data, and the results as well. But remember, memory unit is an integral part of a computer system. The main function of the memory unit is to store the information. Remember, temporarily before we save it. And then we have the output and the input interface. These are used to move the data from the computer to its external environment. So we can use a keyboard, we type in, let's say you type in an email, and then you click send, it's going to go to the network.
Right.
Or it might be saved, it's going to go to the hard drive. So we use the input, and when you do the output, it could be for the network here, to send it to another network outside your environment, or it can be sent to the disk or to the screen. But for them to be able to do that, we have to be able to have the input. Now we use them to move data from computer and its external environment. The external environment may be an input or an output device like a printer, a display unit, which is a monitor, or a CRT, some people call it that, or a keyboard. Now remember also the system interconnection. This constitutes of some mechanisms that provide for communication among the CPU, the memory, and the input-output devices. So here, the bus, this is how we connect. So that's the interconnection, the system interconnection. Now this can be referred to as the bus. So I would like you to remember, like if you're in Atlanta, you can connect from one end of the city to the other end using a bus. So use a bus. So that's an easy way of remembering that. So if you want your information to move from the computer keyboard all the way to the memory and then to the processor, it has to follow the bus. It uses the bus. That's going to be an easy way to remember that. So traditionally, the computer system consists of a single CPU. Most of them, they just have one single. If you look here, this is just one single CPU. Just a very small computer. Now, if you have several computers, like some very large, like computer servers, like they use for like, let's say at Amazon, or they use at Microsoft or at Google, some of them might have more than one of this. And those are very fast computers. But a typical computer in our case here, we use a single CPU. But some machines like multiprocessing machines involving the use of multiple CPUs, and they share the single memory. And we talk of like large memories. So again here, the central processing unit, this is the heart or the core of the CPU. So inside the CPU, inside this particular item here, you see, we have the arithmetic logic unit. We have the registers. Now, I'm going to tell you what a register is. And then we have the control unit, and then we have the internal CPU interconnection, which is the bus. Now, register here forms the internal memory of the CPU. When you type something, the CPU has to have its own memory because it has to do things very fast, but it has to have a way of storing that something before it's saved. So you have the register. So it provides the storage internal to that CPU. And then, of course, now we know what the arithmetic logic unit is. And of course, we know the control unit. The CPU interconnection, provides the communication among the control unit, the ALU, and the CPU. Now, the CPU must carry out the task given below. First of all, it has to read the instructions. Secondly, it has to decode that instruction. And then third, it has to get the operands for execution. And then fourth, it has to process that instruction and then give out or store that result. So here, this is the process. It takes this 1 up to 5 and then 1 up to 5 again. It has to follow that process. Now, to carry this task, the CPU needs to temporarily store some of those data. And that's when it will need a register. So it must remember the location of the last instruction so that it can know where to get the next instruction from. For it to do that, it has to use the registers. So like you have a pipeline of some sort. So each and every instruction has to have a unique ID. So it will be saved in that register, and then the CPU will not have to wait. The CPU will have to go and do other things. And when it comes back, it will grab whatever was left and continue from where it left it at. So the CPU needs to store the instructions and then data temporarily while an instruction is being executed. Now, in general, the CPU needs an internal memory for all storing the instruction or the data. And that says the CPU contains, therefore, a handful of registers, which acts like local variables. Variable is like a temporary memory location. Look at the mailbox, let's say in the neighborhood. Every house has a mailbox. The mailbox might be all look-alike, but each and every mailbox has to have a unique number so that we know this mailbox belongs to the Jacobs. This mailbox belongs to the Georges. That mailbox belongs to John's. The other mailbox belongs to Lucy. So each and every register will have to have a unique ID so that we can be able to remember if we need to come back to that particular item, we will know where it is at. So the CPU run instructions and perform computations, mostly by arithmetic and logic unit. So it does the arithmetic and also uses the logic. Now, when you say the logic, we can say between number 1 and number 10, which one is less? The computer will know by using the logic, it will know that number 1 is less than number 10. And then we can say between this number and this one, which one is on the left of the other one? The computer will use the logic to know that. And that's also same when it uses the internal calculator for computation. And that's where we have the arithmetic and the logic unit. Now, registers are the only memory the CPU has. Register memory is very fast for the CPU to access, since it resides on the CPU itself. So these are all electronic components. However, the CPU has rather limited memory. The registers are not very large, they're very small. Remember, they are very temporary. They're just used on a temporary basis. So we don't need them to be large. We clear them, then we prepare them for the next instruction. So the faster this can be done, the faster your computer is going to be. So we say the CPU has a rather limited memory. All the local memory it uses is in the register. It has a very fast access to those registers, which are on board inside that particular CPU. So it has much slower access to the RAM. So the CPU will have a fast access to the registers, which are actually on board, and it will have a slower access to the read access memory, which is outside its environment. So the arithmetic logic unit is a collection of logic circuits designed to perform arithmetic like addition, subtraction, division, and multiplication, and also do the logic like less than, greater than, not equals to, and way more than that. So it's basically the calculator or the CPU. When an arithmetic or a logic operation is required, the values and the commands are sent to the arithmetic logic unit. Like when you drive, for example, you stop at the stoplight. There's a lot of process we don't know, which is actually happening. How does the light know that they're supposed to now turn green or turn red? Now, if you look, something which most people might not know, on that particular road where we stand or where we stop the car at, on that road there's a sensor. So if there's so many cars, say, bound for east, let's say east towards maybe the city of Atlanta, the sensor will know that it's supposed to make sure that the computer will be able to turn the light green so that these people can pass. So those varies, and whatever makes that happen is actually the logic unit. It has to have a logic. The logic is a way of how the computer reasons. Say today is Monday, it's 8 o'clock. So we're going to have to operate faster. And we are going to be able to sense how many vehicles we have on a 4-way lane. We have to be able to let them pass so that we turn the light green, turn the other one red, turn this green. So that's in itself is a decision making which the computer has to make. But it cannot make that decision unless the CPU is involved. And in the CPU, we have to have the arithmetic logic unit. In the arithmetic logic unit, we have to have the arithmetic side, and also we have to have the logic side. So we do the calculation. Calculation we might just do by checking the time. And then we make a decision by checking the logic. If it's 8 o'clock, then what is the logic? The logic is saying, hey, we need to be able to turn this light on and for a little longer time so vehicles can pass because they're heading to work. That might be different on a Sunday or on a Saturday because maybe sometimes in the afternoon there's not much traffic. Now remember, the purpose of the control unit is to control the system operations by routing the selected data items to the selected processing hardware at the right time. So if we send, let's say we type our information and then we save it, immediately you save your email, it's going to be saved on the hard drive. So you can click on save and then immediately you click on print. The saving will go on at the same time the printing will start. And that can only happen if we control it. We can only control it if we have the control unit. And that's where the control unit comes into play. So it helps make the operation, the system operation, by routing the selected data items to the selected processing hardware at the right time. So control unit acts as a nerve center for the other units. Okay. And then we have the instruction decoder. All these instructions, they come in, but they come in different codes and languages. So all instructions are stored as binary values. They are normally 1 or a 0. So computer will not understand your English or my English, my Swahili or my Arabic, it does not understand. But we have to send this instruction to this computer in the format that it can understand. The computer will not understand either unless the computer has instruction decoder. Now the instruction decoder receives the instruction from memory. It interprets the value to see what instruction is to be performed, and it tells the arithmetic logic unit, and then the registers which circuits to energize in order to perform the operation. So the memory will receive them, the CPU will receive them in the arithmetic logic unit. But remember, without the registers, we cannot put them in a pipeline so that we grab them as they come. We have to have some temporary location to store them while we process them. And that has to be continuous. If it's not continuous, then the computer will be very slow. So you find that the bigger the register, the faster the processor, the bigger the memory will determine how quick your computer is or how best its performance is. So the registers are used to store the data, to store the addresses, and it also flags or store the flags that are in use by the CPU. So we can have the data like your email. Your email, the CPU will have to give it an address. It could be an address which you and I don't understand, but it has to be unique. And then we have to flag it, ready to go, or just put it in the memory. And the CPU will use that to be able to help us to process. The memory is basically a large array of bytes. This one, we just use it like the magnets. The way the magnets store information is very unique. So when they run a circuitry or a circuit or a cable through some memory, which I'm going to show you here what the memory looks like. One second. It's going to be a very simple thing, but it's on that piece of paper I sent you. So it's a computer memory. When you look at the computer memory, this is all you have. This is it. This piece of computer memory. It's not sophisticated, but it's very vital. So let me see if I can give a different angle. This is an old memory type, something like this. So they run cables, so these are circuits through these devices, through these components, which temporarily create some kind of magnetic field to be able to help us store information. Initial stages, we used to have the tape, like the video tapes. Remember those very old ones? That's why they used to save. So it has to do with magnetic field. So nowadays, we just don't use those, but we use more or less this one. These are fast. So the bigger the memory you have, the better for you. It's almost like if you have a bigger brain, you're going to remember more. If you have, let's say, if you're not human, let's say you're just a small bird, they might not remember very, very many things, but again, they still remember. So the memory will depend on the bigger the memory, the better for the system. Okay, so we come back here. Then we say the main function of the memory unit is to store the information needed by the system. So if we store more information, we can process more. If we store less, we will process less. Now, information stored can be data, like what you type in, your name. Your data will be your name, your phone number, your address, let's say your gender, your family name, let's say your wife's name, your kids, those are your data. And then an instruction that is nothing but program to tell the computer what to do with that data. It could be some kind of let's say garbage. The computer, if the computer don't understand, it's going to be garbage. But if you give proper instruction, the computer will be able to figure out what it needs to do with it. So the memory location, or the memory locations that do not contain any valid data, may store some arbitrary values, and therefore they are termed as garbage data. So anything you give the computer don't know what to do with it. We have to give it the instruction. And that's why they normally say garbage in, garbage out. If we give it some really good information to work with, then the garbage is going to turn into useful information. So data is useless information unless we instruct the computer to work with it to make it valuable. At that time, it's going to be now good information. Now, memory unit here is an integral part of the computer system because it almost acts as a brain part, which stores that information. Now, the system performance largely depend on the organization. It could be, let's say, the post office, they store a lot of information. Let's say UPS, FedEx, they store a lot of information. Their computers get really busy, especially during the holidays. Just like Amazon, they do a lot. Imagine what Google goes through. Every day we do a lot of searches, every time, every second, every minute. Now the storage capacity and speed of operation of the memory has to be very key in this process. Now the CPU, the central processing unit, can read or write the memory, but it's much slower than accessing registers. Registers are within reach within the CPU. Memories are very fast, but for CPU to grab that memory part, it's going to be a little slower because it's not within the environment. It's not within the CPU. So nevertheless, you need memory because registers simply hold too little information. The register will be very small, but they are very fast. So they get things coming and going and be able to get rid of it and then store it where it needs to be. So most of the memory is in the RAM. That's the read access memory, which can be thought of as a large array of bytes. In an array, we can refer to individual elements using an index. Index will be a unique number. It could be like something which is very unique. When we look at it, might not make any sense to us, but the computer will understand. Now, in computer organization, for example, indexes are more commonly referred to as addresses, unique address. Addresses are the numbers used to identify successive locations. So say, for example, you live in Atlanta, your home might be similar to other homes in the same area, but your home will have a unique address and unique street number. So it could be, let's say, 435 and maybe Martin Luther King Drive, but the door number has to be there. Otherwise, we'll be on that street forever. Imagine if we had, for example, a GPS, we give it the address, but we did not give it the door number. The GPS will just be on the highway, or it's going to be just on that particular street. Until we give it a particular location or an index or an address, it will not be able to tell. So the address is very important. So the addresses are the numbers we use to identify successive locations. Specifying the address and command that perform the storage or retrieval process as we access different locations. So here we have the CPU. With the CPU, we have registers in it. And then this one is the memory, which is the random access memory. But remember the bus, which transports the information between them. And remember the address bus. So we have the data bus for transporting data. And in addition to that data bus, we have to have an address or an index to be able to help us identify it. For example, we can say the data which is coming from this CPU, we want it to go to this particular memory. But unless that data has an address, we cannot identify it. It's almost like a letter. We have to have a letter. In order for a letter to reach you, we have to have a letter with a name on it. And then with that name, we have to put an address so that we can bring it to your door. So that's exactly the same here. So this take data bus as the envelope. Envelope can mean anything. How many, let's say how many Jacobs are in that neighborhood. We have to say we want it to go to Dwight Jacobs. And then Dwight Jacobs might be more than one in that neighborhood. And then we can say, okay, then it's 410 Martin Luther King Drive. It's going to Dwight Jacobs. But again, we have to give it a door number. So let's say it's going to door number 1130. Then that will be tagged properly. So the address bar is the envelope, but the address name is going to be the bar, the address bar. So the number of bits in each word is called a word length. The number of bits, like the bits will be 0, 1, 2, or 0, 0, 0, 0, 1, 0, 1, 0, 1. Those are bits. 1 is a bit, 0 is a bit. Several bits can be brought in together, and those bits in a word are known as the word length in a computer. Now, large computers usually have 32 or more bits in a word. The word length of a microcomputer, like your laptop, ranges from 8 to 32. But that changes with the computer generations and also changes the computer speed. Very old computers could have very small word bits, like 8. We went to 32, some of them now going up to 64. So your computer might be very fast because it can take more word bits or word length. The capacity of the memory is one factor that decides the size of the computer. Data are usually manipulated within the machine in units of words, multiples of words or parts of the word. So if you can type a long word, 8 characters long, that's going to be 8 bits. If you type 32, sorry. Nothing.
Hello, Moto.
Yeah, somebody's trying to call that. I have to hang up. Okay, sorry about that. So most memory, okay, if you type 8 characters long, that's going to be 8 bits, and that's going to be the word length. Some of them will allow you to type up to 32 bits. That's going to be word length. That's going to be 32 bits. Now we have bigger and bigger computers accepting 32 times 2, which is 64. The capacity of the memory is one factor that decides the size of the computer. Data are usually manipulated within the machine in its units of word. Now, multiples of words or parts of word. During execution, the program must reside in the memory. Now, let's say you start a word program, you want to type your word program. When you start that word program, the word is sitting in the memory. So your word program you run right now might not have fitted in the computer, which was probably bought, let's say, in the early 1992. Those were probably, most of them were 8-bit computers. Now the word program right now, most likely running a 64 bits or a 32-bit program. So when you start that computer and then you start the word program, that word program will be able to work because the computer capacity you have is able to make that reside in the memory. Now, instructions and data are written into the memory or read out from the memory under the control of the processor. And also remember, most memory is byte addressable. So most memory are in bytes. So they are byte addressable. They have to be in bytes, meaning that each address refers to byte of memory. Now, the bulk of the memory is stored in a separate device called RAM. That's the read-only memory. Read access memory, usually called the physical memory. Now, remember, RAM stores program as well as data. So RAM will store your Word document plus your Word program. The CPU will fetch instruction in the RAM to a register which is referred to as the instruction register. Now, this register then determines what instruction it has and then executes the instruction. So in your Word program, you can send a save command. The save command will go straight to the CPU. The CPU will have to determine and then send the command back and forth until it does its job. And this happens within milliseconds. So executing the instruction may require loading data from your RAM to the CPU or storing data from the CPU to the RAM. The time required to access one word is called the memory access time. And those are normally in milliseconds for those very fast computers. So they run very quick. And then remember, we do the classification of memory system on the computer. Remember, we talked about the RAM and the ROM. Now here they're talking about the internal memory. And then we have, which refers to the CPU registers. Now this serves as a working memory, storing temporary results during the computation process. The word temporary is key here, because if you lose power, they're gone. They form a general purpose register file for storing the data as it is processed. Since the most of these registers is very high, only few registers can be used in the CPU. The cost of this register are very high. So they put, let's say, if it's your laptop, let's say it's 5i Pentium or AMD, they can only put a small amount of registers in a CPU. If they put more, then that computer will definitely become more expensive. The primary memory is also called the main memory, which operates at electronic speeds. They're very fast. CPU can directly access the program stored in the primary memory. But remember, they are fast and they can be accessed faster, but the access to register is faster than access to the primary memory by the CPU. So the main memory consists of large number of semiconductors, storage cells. So like I said, in here, or better in here, these are circuits. So these are semiconductors, but we surround them with cables. These are cables. These are gold plates. We use gold because gold, though it's very expensive, but it's very fast in conductivity. So when they pass power through these semiconductors, the more the semiconductors, the higher the capacity of the memory. When they do that, they store more and more of what is needed to be stored. And that's why when we come here, it's saying they are able to store more in those semiconductors. So each cell is capable of storing 1 bit of information. Now, what is a group of these cells? Main memory is organized so that the contents of one word contained in bits can be stored in and retrieved in basic operations. And then we have, remember, we have the internal, primary, now we have the secondary. Now this memory type is much larger in capacity and also much slower. Secondary memory stores system programs, large data files, and information which is not regularly used by the CPU. So in this case, you might be talking of a hard drive. When the capacity of the memory is exceeded, the additional information is stored in the secondary memory. So this is a hard drive. From the secondary memory, we access directly through the input-output programs that transfer the information between the memory, main memory, and the secondary memory. So if you have a thumb drive is going to be a secondary memory. If you have a hard drive or external hard drive, those are secondary memory. And then now we have what we call the cache memory. The performance of a computer system will be severely affected if the speed disparity between the processor and the main memory is significant. So between the processor, the CPU, and the main memory sits what we call the cache, the pipeline. It's almost like a pipe of water. You send water through it, and that water has to be contained and delivered. And you keep on sending and contained and getting delivered. If we burst it or we don't have it, then we're going to have a problem in delivery, and that's going to slow the system down significantly. The system performance can be improved by placing a small fast-acting buffer. Buffer is something like a temporary memory between the processor and the main memory, and that's what we call the cache memory. This buffer right there, the cost is very high. So when you buy a computer which is very expensive, you're going to be looking at the cache memory, which they will normally write there, maybe 256, and then they give you the number of registers that computer has, which actually sits, is a memory which sits inside the CPU. So the registers, the cache memory, how big is the processor? The processor, they're going to tell you, for this particular processor, we give you this cache memory, and with this, we give you this cache, we give you this register numbers. And those are normally very expensive. So the expense really varies. So sometimes you see some laptops, they're costing $400, but other laptops, they're costing $1,500. But when you look really deep, if you know what you're looking for, then you'll see the difference. You'll see the usability, the user friendliness of these other very expensive computers. And this keep on changing. You might buy a computer today at 1,500. Next year, the same time, that computer will not be the same. Other computers which are faster than it will be more than that amount of money, but this one will probably be still faster. So it really depends on the user. You know, some of them are very cosmetic. You might just buy a computer because you like the color, you know. So they can always play with your head that way too. So that, I'm going to say, will bring us to the end of this session today. I don't want to give you more than what you can chew for today, but you have a lot of reading. Huh?
That was enough, man. I'm definitely going to have to do this again, but okay.
I'm going to, tomorrow we're going to meet again. So I'm going to send you some notes. When you get time, if you have a printer, some of these are very printable. The book might be too large for you to print the whole thing.
Right.
But what I'll do, I'll send you, I'll look around for discount and then send you a link and see if you can get it online.
Okay.
It might also be good to have it physically. So maybe sometimes you just want to be on your bed or on your couch, then you can read it. But the course will involve a lot of your input in terms of practicals. When you get that computer, don't be afraid to open it up, test stuff.
Okay.
Yes, sir.
No problem. That's no problem. Like I said, we're going to try to run by a computer store tomorrow when we get out of church.
Yes, yes. Just get an old one, something which is probably cheaper than $50.
Yeah,
some of them are very old. Yeah.
Okay.
Yeah, this will help you become very comfortable with the computer, so you can be able to look at it, open it, you know where things are, because in the process of this course, you learn a lot of things, including the error codes. If a computer is turned on and, for example, you hear a particular kind of noise, you'll be able to tell what's wrong with the computer. Or when you see a screen, you'll be able to say this is something wrong with the computer. And then you can open and directly go to that part and fix it.
Okay.
Yes, and that's why they get paid high.
Yeah. Oh, yeah.
Yes, sir. All
All right,
right,
I
so we are good.
appreciate
I'm gonna send you some link, and then we'll meet again tomorrow same time.
Okay. All right.
Thank you, sir.
Appreciate it, sir.
No
Take care, man.
problem. You too.
Thank you. All right. Good night.
Okay. Good night.